So once we have selected a method, we can develop an appropriate procedure. And there's a few things we need to think about when we develop procedures. Obviously, we need to make sure that we've sampled correctly, so that we've taken samples which can accurately represent the thing that we're trying to measure. And we'll talk about sampling in a future chapter. Then we need, in most cases, to calibrate the method. So most methods you cannot directly convert the signal into the concentration or the mass that you're interested in. So there needs to be some way of changing from, or taking the signal and converting that into a concentration or mass. So what we normally do is plot the signal against the concentration or the mass that we're looking for and get something called a calibration curve. And again, we'll go into calibrations in more detail. So this is an example of a calibration. These are measured standards. Standards are things of known analyte concentration. So you can plot the concentration and measure and get a signal, and hopefully get a nice straight line. Then from that, from an unknown, you can measure an unknown, get a signal, and then convert it into a concentration, either directly from the graph or more commonly from the equation from the line. And you'll see in this case I actually have a negative blank value. So this would mean there's some kind of interference there, some kind of reagent signal that we'd have to correct for. Once calibrated, we need to validate. We need to find out if our examples or our answers are in acceptable range in terms of accuracy and precision. And there's a couple of ways you can do that. You can compare to a method that you are confident gives good accuracy and precision, or we can use something called a standard reference material. So this is an example of an SRM, standard reference material, from the National Institute of Standards and Technology. This is trace elements in a natural water sample. So this is, or standard reference materials are basically materials which have been analyzed by a number of different techniques, a number of different labs, and so they have certified values. And you can get all different types of SRMs. This is actually water taken from Clear Creek, Colorado. So it's been measured a number of times, and they actually give you certified values. So here we'll tell you for each element that they've looked at what the mean is, and some idea of the spread, some idea of the precision. So you can compare your value to these values and see if your method is giving acceptable accuracy and precision. And these will also tell you all the different techniques that we use in order to get these certified values. So that's validation. All these things are combined in a protocol. So this is an example of an EPA protocol, kind of a flow diagram. And you'll see that it combines calibration, it also combines validation, as well as quality assurance, quality control measures that again we'll talk about later. But all these things are combined in the protocol. So you start off with initial calibration, and the protocol tells you how to do that calibration. You have initial calibration verification, initial calibration blank, to make sure that your calibration is correct. And as long as those values are in acceptable limits, you can continue. There's also a continued verification, calibration verification, and continued calibration blank. If those are acceptable, then we can run samples, but we also go back and we check. So we do this QA, QC procedure. And then if that's acceptable, we can carry on and do more samples. So all these things are kind of combined, and the overall purpose is to make sure that results we're getting are within acceptable accuracy and precision, and continue to be within acceptable accuracy and precision.